सो क्वांटम मैकेनिक्स यूज़ कर रहे हैं अपन, है ना। पार्टिकल इन 3D बॉक्स। तो हमको पता है, अपनों ने पढ़ लिया 1D पढ़ लिया अपनों ने, क्या था n स्क्वायर पाई स्क्वायर h क्रॉस स्क्वायर अपॉन 2m स्क्वायर, और अगर यहाँ पे अपन h स्क्वायर कर देना चाहता है 8m स्क्वायर। ये था उसका आइगन फंक्शन, आइगन वैल्यू एनर्जीज की। और फंक्शन क्या था, √2/a sin n π/a इंटू एक्स। तो 3D बॉक्स में क्या हो जाएगा, 3 डायरेक्शन आ जाएगी। तो √2/a √2/b √2/c sin n π/a sin n π/b sin n π/c with respect to x y z direction. So total wave function will be √a upon a b c sin nx/a by x sin ny/a pi y sin nz/a pi z. This will be the wave function with respect to a particle in a 3D box where n are 1 2 3. Okay, so from this we know the propagation square of the sum of square of the propagation vectors will be equal to k square, and that is 2m upon h plus square. So what is here, k equal to n/a, we know that, and ky be equal to ny pi, and k2c equal to nz pi. So from here what we can say, pi square nx square upon a square, ny square upon b square, and z square upon c square equal to 2m upon h cos square. That is the k square. So simply we are calculating value of k, kx, ky, and kz, and then squaring and then summing them up, and we will get this value. So from here E equal to pi square h cos square upon 2m a square, nx square upon a square, ny square upon b square, and z square upon c square. So in 3D what we are having, energy eigenvalue of 3D will be equal to nx square plus ny square plus nz square times of E1 1D. कितना था, पाई स्क्वायर एच को स्क्वायर अपॉन 2m a स्क्वायर. दिस वाज द आवर बेसिक वैल्यू फॉर द 1D, and 3 times of it because 1 1 1 is there, so it will be 3D particle in a 3D box. So this is the ground state. Now ground state is 1 1 1, so it will be 3 will be there. Pay attention very keenly on my words. Now when we go first excited state, then what will happen, these are 1 1 1, so introduce 2, so they can be 3 generated state, 2 1 1 1 2 1 and 1 1 2. Okay, so degeneracy will be 1, and when you square and sum up will be 2 ka square 4, 1 plus 1 4 5 and 6, so 6 pi square square upon 2m square. Similarly with second excited stage, what is happening, 2 2 1, first 1 1 1, then 2 1 1, then we are including 2 2s, 2 2 1 2 1 2 and 2 2 1 2 2, so it will 2 ka square 4, 2 ka square 4 and 1, so total 9 pi square upon 2m a square. Third excited stage 11 E1 1D, so 11 pi square upon 2m a square. So what is the degeneracy, degeneracy is 3, and what is the sum of eigenvalues, 113 311 and 131, so 11 pi square upon 2m square, and with fourth excited stage will be 12 E1D, 12 will be there, and degeneracy is 1331. Okay, remember that. So ground state 1 1 1, for first excited state will be 2 introduce 2 1 1 1 2 1 and 1 1 2. For second excited state will be 2 2 1 2 1 2 and 1 2 2, and third excited will be introduce 3 1 1 3 3 1 1 and 1 3 1, and then 2 2 will be the fourth excited state. Very easy peasy, and degeneracy with respect to first excited state are 1 3 3 1. Just remember this. So average value, expectation value of xn will be a by 2 for the 3D box, and we know this probability. The probability of x nth state will be 0, and expectation value of x is momentum operator. This is the momentum. Okay, not probability, this is the momentum. So average value of momentum nth states x momentum will be 0. Similarly py and pz, and expectation value of xn square equal to a square 1 by 3 minus 1 by 2 and pi square. From here you can calculate this. Just remember, expectation value for the particle inside a 3D box, and square of the xn square expectation value will be a square 1 by 3 minus 1 by 2 and pi square. And if we calculate the x square expectation value of the square of the momentum will be n pi h cos by a square. Just remember these values, he may ask you in exam. Now finite height potential box. Suppose we have finite potential box like this, and it is potential 0 from 0 say a, and outside these walls potential is v0 when x is not equal to 0, x greater than equal to a. So just calculate for psi second, means in this region. So d to second d square 2m upon h square psi second. So k is this. So will be solution of the wave function is a sin kx, because kx. Now apply boundary condition and you can calculate the value. Now for d psi first, this is the phi and this is third. So d psi first upon d x square plus 2 h cos square and e minus v naught. Okay, e minus v naught, because v naught is less than e. सिमिलरली फॉर साई थर्ड, बस बाउंड्री कंडीशन बदलेगी, क्यों? क्योंकि ये वाला है फर्स्ट एक्स लेस देन इक्वल टू 0 के लिए और ये वाला एक्स ग्रेटर देन इक्वल टू ए के लिए. सो जस्ट अप्लाई द बाउंड्री कंडीशन एंड यू विल हैव डी साई फर्स्ट डी सी स्क्वायर minus 2 m का स्क्वायर v नॉट minus e. Why we are taking minus outside the bracket? Because we know that v naught is greater than e. Energy of the wave function incident on the x equal to 0 while is less than the potential barrier. So it will lead to c e to the power alpha x plus d e raised to the power minus alpha x. And for psi third, this is the reason. So psi third, what will happen? 2 upon h square h cross square e minus v naught psi third. So similarly, same minus common, c e raised to the power alpha x plus f raised to the power minus alpha x. So when you put boundary condition this at x equal to 0 and x equal to a, at x equal to 0 psi first equal to psi second, x equal to a psi second equal to psi third, wave function and their first derivative. So psi first will lead us to de minus alpha x. This is the psi first. Okay. And for psi third, f e raised to the power minus alpha x. So it is showing us that particle will have probability finding out it in classical forbidden region. So it is showing us that particle can be found in classical forbidden region. There is certain probability. Probability is not 0. This is the classical forbidden region for first and third. So in both these regions, particle can be found. Here also. Now we'll discuss about step potential, because it's just like stair. So this is the v naught partial barrier is equal to 0. First and second, only two reasons are possible. Now, so x not equal to x less than 0, potential 0, and x greater equal to 0, v naught will be there at the walls. So case first we take, suppose we are having energy less than potential v naught. This is the energy particle have, suppose. Now we'll discuss this case only. Okay. So what will be the equation? D to psi upon d square plus 2m upon h square e minus v naught psi equal to 0. So reason first, e less than v naught. Use this equation, because in this reason what is potential is 0. Simply this equation will lead to this. We consider k is this, and in reason second what is happen? Potential is v naught. So just put potential is v naught, but simply we know e less than v naught greater than, so minus will be coming out here. That's why it's minus. It's minus, and we consider alpha equal to root 2 upon h cross square v naught minus e. So the equation lead to this. Now here is a minus sign, so it will goes to plus minus alpha, means equation will be in real form. So c e to the power alpha x plus d raised to minus alpha x for x greater than 0. But for this reason it will go to plus minus k iota. So it will lead us to complex equation a e to the power iota kx plus b raised to minus k iota kx, and where this is the incident wave and this is the reflected wave. We know the wave function psi of r. We have two functions psi of r, simply for position and time. So this is depend on time, this is depend on space. Combinedly we will return is e raised to e to the power iota kx minus omega t. So from here, if we compare sign, if both are in opposite sign kx and omega t, positive x direction, if both are in same direction, negative x direction. So look at the psi second. What is happening here? At x equal to infinite, what is happening at x equal to infinite? It is giving us infinite value, which is not possible. Okay, so c will be 0. We only left with d to the power minus alpha x. What this is representing? It is representing transmitted wave, because in second region there is no boundary. So there is no question of reflecting it back. It can only go through, it can only transmit through this wall. That's why C is 0, only D part will be there. Now if you apply boundary condition, same thing, so we'll get D and B, coefficient D and coefficient B. From here also we can have some thing to keep in mind, that here x is positive and when we write a sin kx minus omega t, so kx and omega t are in opposite direction, so it will be in this direction. This is incident wave, and here minus iota kx minus iota omega t, iota x and omega t both are in negative, means both are same sign, so it will be in negative x direction. So negative x direction means it is reflecting back. Hope you understand what I just had said. Okay, thank you. Now pay attention on the upcoming part. So when you apply this boundary condition, what you will have, हमारे पास क्या प्राप्त होगा, d equal to 2k upon k plus iota alpha a and b is equal to k minus iota alpha k plus iota alpha a. Okay, there is no language barrier here. Okay, we can learn in Hindi and we can learn in English as well. So as you prefer language, we can modify our content accordingly. The medium of instruction means in written it is English, but in explaining it either can be Hindi or either can be English. There is no question about this. So tell me in whichever language you are comfortable, we will use that language. So now we'll calculate about the current density for region first and second. So this is the region current density fault, and when you solve it, J equal to V and dot S comma B square, and S less than 0, and V is velocity of the particle here. So reflection coefficient is incident and reflected back, B square by A square. Remember in examination they ask this is step potential. Remember, most of the time it may happen that because there are many cases, there are many problems, so we'll forget which problem you are solving. Okay, so just remember always which problem you are dealing with. So at present we are dealing with step potential, and for step potential we are having current density equal to V A square minus B square, and reflection coefficient is k minus iota alpha by k plus iota alpha square, which is 1. And for so in a E less than 0 region there is no transmission, only reflect and reflect back is possible. So this is V1, so R is 1, so T will be 0, and psi second is this. So probability of the wave function second, which is non-zero. So what does it telling us? So particle has finite probability yet exponentially decaying to transmit in region second. Because particle is here, it has energy less than the Potential barrier, so it is having classical region, but it has certain probability of having in this second region. How it will go in second region? So we will say it gets tunneled, or we say it has exponential decay probability. That's what I am saying. Okay, hope you understand it. Now conclusion is, now whenever we are increasing V0, what we are increasing? We are increasing alpha. So whenever you increase alpha, what will it decrease? It will decrease the probability of particle having in the second region. So this is the dependence of probability of the particle finding in the next region on V0. Now pay attention to the second part. When E is greater than V0, this was 1, this much was 1, this much was for E less than V0. Now E greater than V0. So what will happen? This is the for region first. Okay, now for region second, this will be the answer. So for psi first, what we are having, a की power iota kx plus b e raised to the minus iota kx, and psi second is c raised to the power iota k prime x and d e raised to the power minus iota k prime x. So what will be the answer for this two? What it's showing, this is the incident part and this is reflected part, and this is showing us iota with iota and positive x. So this it will go in positive direction and it will go in negative direction. From where we have taken this information, just revise the video 5 minutes back, you will realize. So there is no boundary after x greater than 0, so reflection is not possible after this part. So reflection is not possible, so d will be 0 for E greater than V0 part. Now when we apply boundary condition, what we are having? We are having similarly two things, B by A and C by A. This is R and this is T. So J current density will be for first B A square minus B square, and second equal to V dash C square, and reflection coefficient k minus k prime square but by k plus k prime square. What was here? K minus alpha and k plus alpha, and here is k minus k prime and k plus k prime. So remember the condition, step potential E greater than V naught, reflection coefficient is k minus k prime by k plus k prime. K is, what is k and what is k prime? These. Okay, don't forget these things. Okay, so R will be lead to this and T will be lead to 4k by k prime by k plus k prime square. So for E greater than 0, what is the conclusion we are having? Whenever we are increasing E, K will also increase and reflection coefficient will decrease and transformation coefficient will increase. Okay, this dependency should also be remembered to you. It may ask an examination that for a step potential if E is greater than V naught and we are increasing E, then what will be the effect on reflection coefficient or transmission coefficient? So when you are increasing E, what is happening? K is increasing, so R will decrease and T is increase. Second, when E is greater than V naught, what will happen? R not equal to 0. Now this is the for E less than V naught, this is for E greater than V naught. So for E less than V naught, what will happen? R is 1 and T is 0. And value increase E greater than V naught, what will happen? Decay, exponential decay. This is exponential increase. This is the graph. This will be transmission coefficient. Here also, what is happening here? This and this. Now we'll discuss about potential barrier. Okay, so this is the potential barrier. There are three reasons. So when in this region potential is 0 and between this region this is V naught. That's why we call it as potential barrier. So okay, take first case when E less than V naught. So region first and region third will be same. So both equation will be same. K will be same. Only boundary condition will be different. Both have same answer A and B, and here we take coefficient C and D. In this part there is no boundary, so no reflection is possible, so D is 0, so only simply C is there. Now what will happen in region second? This will be happen in region second. Now E less than V naught. E less than V naught, that's why we have taken minus common outside. This is the reason. So when E less than V naught, we are having alpha square. This is the alpha square, and we have calculated the answer for this wave function. Psi second equal to f e raised to by alpha x, because it will be in plus, so real values. Okay, now we apply boundary condition for this and this. So you are having current density V a square minus b square 30 VC square, and reflection coefficient is 1 plus 4 e v naught minus e v naught square sin hyperbolic square alpha a. Similarly for transmission coefficient 1 plus v naught square sin hyperbolic square alpha a by 4 e v naught minus e inverse. Now there are some important points we should remember. When we take limit E as P naught, alpha will tend to 0 and sin theta will be theta. So this will be the our alpha. So when you are putting limit E tends to V naught, T will be minus. So 1 plus m v naught square a square by 2h square minus inverse. So m v naught a square upon 2h square will be opacity of barrier. So when you increase this, okay, opacity of barrier will be increased, so transmission will be decreases. Getting my point? Think for the 10 seconds. When you are increasing opacity of barrier, means width increasing, A is increasing, so what will happen? T will decrease. Second, similarly when you increase A, this is A increase, T is decreasing this A, and when in second part you will increase A, so transmission will decreases. Similarly, when you increase V0 increase, transmission will again decrease. Remember the formula. And alpha I greater equal to 1, so it will be very easy for you. Sine hyperbolic will be e raised to power alpha I minus e raised to power minus alpha divided by 2. So when alpha is greater than 1, so e minus infinity equal to 0, so will lead to this. Just put this value. So what is showing? Is showing the transmission is decreasing exponentially in this region, in the second region. Hope you got the point. So in classical region, all good. In classical forbidden region, or we say in quantum region, exponential decrease. Now second, step potential, potential barrier. This is the potential barrier. This is the potential barrier. Second part, d2 psi second upon dx square plus 2 upon square e minus v0 psi second equal to 0. So it will be k prime square because e greater than v0, all good. So it will lead to plus, so it will lead to minus, so it will be complex part will be there. When you solve it for e not now, near hyperbolic only sine square. Just inverse this, okay, inverse this term. So for e greater than t is less than 1, still reflection possible, finite probability of getting back reflected. So क्या हो रहा है? When energy is greater than the potential barrier V0, transmission is less than 1. It is positive 1 by something. So transmission less than 1 means there is still some chances of getting reflected in the same region. Now we'll take some special cases. So sin k pi equal to 0 in the condition of a equal to n lambda by 2. So for these reasons, transmission 1 and r is 0. So it is what is happening here, destructive interference is happening here by various in region second. So it will be the graph exponential decay, then this and this part will be there. Now we will discuss about some numericals. So here is our first question. The ground state energy of a particle is finite, square value is 1 electron volt. If 4 particles obeying both Einstein statistics are kept in this well, then the ground state energy will be. So if the ground state energy will be 1 electron volt, there are 4 particles and they are following both Einstein statistics. So what does it refer? It means multiple particles can occupy the same quantum state. There can be multiple particles in the same quantum state. We call it degeneracy. Okay, so ground state will be 4 times of this and it will be 4 electron volt. Now we have given a figure, and what is given to us? The energy eigenvalue of the state is 2 electron volt and it is finite square wave. What is the energy eigenvalue of the particle in the ground state? So for the ground state we have to calculate the energy eigenvalue. So for calculating ground state energy eigenvalue, what you should know? You should know the value of n, because a equal to n square pi square h square upon 2m a square. So for this you should know n. So how you can calculate n? How will you calculate n? So for calculating n, you should know that if there is one node point, then will be n plus 1 n, because node point is always n minus 1. So there is one node point, means n equal to 2. That's what I am saying. So what is the ground state energy given to us? It will equal to 2 electron volt. That what does it mean? Okay, now E equal to n square pi square h square upon 2m a square. What is the a here? Not 0 to a, minus a to plus a, so total end will be 2a. So it will be n square pi square h square upon 2m 8m a square. Basically it will be 8m a square, or it will be 4m a square if you put here. And ground state energy 2 electron volt and value of 2n is equal to 2. So just put it in this and it will be this. So ground state energy will be pi square h square upon 8m square. From here we can calculate n equal to 1. So pi square h square upon 8m square. So what is pi square h square upon 8m square? 1 by 4 of pi square h square upon 2m square. And what is pi square h square upon 2m square? 2 electron volt. Just put and know the answer. So for solving this question, you must remember only 2 to 3 things. Just calculate n, okay? And if you know the n, and energy eigenvalue of that state means E2. E2 is given to us 2 electron volt. E2 is 2 electron volt. So just put in the formula. What is E2? E2 is n square is 4 and 4 pi square square upon 8m square. Okay, so 1 by 2 will be 8m square. सिंपली कहानी इधर से पकड़ो इधर से पकड़ो, आंसर तक पहुंचना है अपने को. अब देखो अपना क्या है, एक यहाँ पे एम स्क्वायर ओमेगा स्क्वायर एक्स स्क्वायर दे दिया, तो ये क्या होता है, हाफ ओमेगा स्क्वायर एक्स स्क्वायर क्या होता है अपना, ऐसा जो होता है. द ग्राउंड स्टेट वेव फंक्शन है विच इज द पार्टिकल, इट इज हाफ हार्मोनिक ऑसिलेटर. सो फॉर हाफ हार्मोनिक ऑसिलेटर ग्राउंड स्टेट विल बी 0 at x equal to 0 and x equal to infinite. So only this is satisfying this condition, no other option is satisfying the condition. Again same, it will be half harmonic oscillator and is this but only for odd functions because Vx infinite plus x dash. Now standing wave with wave function a sin k corresponding to particles m give rise to current density. So sorry for the disruption. So standing wave is, where were we, this question. Okay, so here was the weight function sin a sin kx corresponding to particles of mass gives rise to current density equal to, so just remember this is the real wave function, a sin kx is the, of course it has complex part too, so h goes upon 2 m psi star del psi minus psi del psi star. So what will it lead to, its complex conjugate will be same and also same, so it will lead to 0. Getting my point? Means what will happen, this wave function complex conjugate same and del psi cos kx same here. So it will be 0. Now again next question, a particle moves in 1D potential Vx at is equal to a, if V has finite discontinuous jump, then what is the following true? This question we have done earlier also. Both phi and phi dash are continuous, means their first derivative of the function and function itself must be continuous. Now the wave function of a particle moving in one dimensional time independent potential Vx is represented by psi x e raised to power minus iota kx, where a and b are a real constant. This means that the potential Vx is of the form is equal to constant. This question we also have done this. I can show you, but we have to go back. In previous lecture you will see it will be constant, means when you put that Hamiltonian part and solve that, only power iota x psi will be there and b square direct proportional will be there, so this will be constant, not dependent on x basically. Okay, don't confuse with this. Okay, this is plus b, not plus b, so whole wave function will be, is not possible. This will, when you solve it, not, if you don't want to solve, just look at the previous lecture and you will find this question solved. The expectation value of momentum for a bounded state finite square wave potential width a depth is 0. मोमेंटम की एक्सप्रेशन क्या होती है, अभी पढ़ा, px क्या होता है, 0 होता है, सबको पता है अपने को. ये px क्या है, 0 है. पेन कहाँ गया, चलो बाद में दे दो. नेक्स्ट क्वेश्चन. ओके, for attractive one dimensional delta potential situated x equal to the wave function of the bound state given by, so this is the one dimensional potential and situated x equal to 0, so at x equal to 0 this will be 1, and if you put this e raised to power minus alpha x, take this bound state, so it will lead to this. So answer is a e raised to power minus alpha x. A is one normalized wave function. Now 5 electrons fermions with spin 1 by 2 h cross are kept in a one dimensional infinite potential where width of a ground state energy of single electron is this. The first observation line correspond to energy. So this is given to us, energy is pi square h square upon 2m square. So what is this, पार्टिकल ने बॉक्स मान लो इसको, है ना, सेम ऐसे ही. सो क्या होगा इसका, एब्जॉर्प्शन लाइन निकालनी है. ओके, फर्मियोन्स के एस्पेक्ट में, किस में पढ़ा है, इनफाइनाइट पोटेंशियल वेव के एस्पेक्ट में पढ़ा है. सो ग्राउंड स्टेट दी है, तो क्या निकलेगा अपने को, फर्स्ट इक्वेशन कहाँ से होगा, 2e और 9e. ओके, n equal to 1 is ground state, n equal to 2 and equal to 3, so 9 into t 2e, so 9 minus 2 equal to 7e, and this will be e. Now and idealize their annihilation and creation operators. This will create and this will decrease. So we have to calculate this part. Remember, A is annihilation and idealize creation. So this is annihilation operator. Means it will give you simply it will do -1. Okay, so this will be -1. Simply this and our last answer will be n plus 1. Very easy peasy question is there. Many times this question has been asked. Okay, just remember this. Now very important, we have just done this. Now step potential E greater than V naught. I will show this to you. Where is the step potential? This is the step potential. This is the step potential, and E greater than V naught. E greater than V naught. So just remember, this is the reflection coefficient and this is the transmission coefficient. K minus K prime by K plus K prime square and 4K K prime by K plus K prime square. Yes, reflection coefficient is this. K minus K prime by K plus K prime square. Now next question. Simply we have done this question for the simple harmonic oscillator, half harmonic oscillator, only odd and odd only. At equal to 0, no dimension harmonic oscillator in the given state is there. What is it asking us? First, to normalize eigenstate is natural angle of frequency of the oscillator, then the expectation value of the energy. अपने को क्या निकालना है? Expectation value of the energy. So this is the function. So what will the energy value? Expectation value of the energy. This absolute probability and E naught ground state energy and first excited into P1. So just remember, what is the probability? Here 1 by 2, here 3 by 4, P0 1 by 2, here 3 by, so 1 by 4 and 3 by 4. And what is energy eigenvalues? From calculate from this, n plus 1 by 2 h mu, which h mu by 2, n equal to 0 and n equal to 1. Put those in here. So you will have the answer 5 by 4 h mu. For a finite square wave potential in one dimension, it is possible that no bound state exists. No, this is not possible. There is always at least one bound state to be exist for a finite square wave potential in one dimension. The number of bound states that a quantum mechanical one dimensional finite square wave admits depends on both depth v naught and width of the अभी पढ़ के आए ऊपर ये अभी बताया मैंने पूरा स्क्वायर वेव्स में विड्थ पे भी डिपेंड करता है वी नोट बढ़ेगी तो भी ट्रांसमिशन घट जाएगा और ए बढ़ने से भी ट्रांसमिशन घट जाएगा तो डिपेंड करता है क्या डिपेंड करता है बाउंड स्टेट दोनों की वही सेम क्वेश्चन हार्मोनिक ऑसिलेटिंग विद फ्रीक्वेंसी ओमेगा नॉट मैंने परफेक्ट रिफ्लेक्टर इंट्रोड्यूस एट द ओरिजिन द फ्रीक्वेंसी ऑफ ऑसिलेशन बिकम्स ओमेगा 1 इज गिवन बाय तो क्या होगा ओमेगा 1 क्या होगा ओमेगा 1 इसमें से इसको माइनस कर दो क्या आएगा तो ओमेगा नोट आ जाएगा ग्राउंड स्टेट में क्या था ओमेगा नोट और परफेक्ट रिफ्लेक्ट में क्या जाएगा ऊपर चला जाएगा so 1 plus 1 by 2 3 by 2 some questions are very easy okay and minus 1 note points will be there we know this so fourth excited state means n equal to 5 remember fourth excited state means n equal to 5 ओनली SHO चालू होता है कहाँ से n इक्वल टू 0 से बाकी सब ऊपर से चालू होते हैं नाउ वेरी गुड क्वेश्चन क्या निकालना है अपने को ग्राउंड स्टेट एनर्जी निकालनी है किसकी इसकी तो क्या करो लगा दो हैमिल्टन ऑपरेटर माइनस एच के स्क्वायर अपन 2m शाई स्टार डी 2.6 स्क्वायर साई सो स्क्वायर करेंगे तो ये वाला टर्म तो यहाँ से आ जाएगा 2m भी आ जाएगा और क्या करेंगे एक बार ये वाला फिर डी 2/d स्क्वायर ये वाला सोलो कर लो तो इतना आएगा और आगे सोलो करो 0 से में तो a³ माइनस a³ बाई 3 so lead to 5/8 h square upon m square so there is no option correct answer is 5/8 h square upon m square now a particle is constant to move in a truncated harmonic potential well as shown here half harmonic oscillator which one of the following statement is correct हाफ हार्मोनिक पोटेंशियल है n plus 1 by 2 h mu सो n इस क्या है ओड है n सारे क्या होते हैं ओड होते हैं तो क्या बोल रहा है फर्स्ट एक्साइटेड स्टेट So n equal to 1, n equal to 0, n equal to 1, n equal to 3. So 0 is not possible, so n equal to 1 is ground state, n equal to 3 is first excited state. Put n equal to 3, 3 plus 1 by 2 equal to 7 by 2. Okay, एक हाइड्रोजन नंबर का फंक्शन दे दिया अपने को और अपने से पूछा है वैल्यू जो एंगुलर मोमेंटम का एलजेड निकालना है अपने को, एक्सपेक्टेशन वैल्यू ऑफ एंगुलर मोमेंटम एलजेड. सो आएगा h cos by 8. अगेन द मिनिमम डेप्थ ऑफ द पोटेंशियल में एनर्जी आइगन वैल्यू निकालनी है बेसिकली. सो क्या होता है एन स्क्वायर बाई स्क्वायर h स्क्वायर 2m a स्क्वायर. ठीक है, और इसको h के फॉर्म में लिखें तो क्या आएगा 8m स्क्वायर आ जाएगा. अगर h क्रॉस में लिखोगे तो 2m स्क्वायर आएगा और इसमें लिखोगे तो 8m स्क्वायर आएगा. Given that cat of 1 0 and 1 1 and 1 are the ground first excited, this is the ground, this is first one dimensional harmonic oscillator, the uncertainty position for a particle in the state given by, ये uncertainty है तो अपने को पूछा है कि इसकी uncertainty का वैल्यू क्या आएगी. सो इट विल बी डेल्टा एक्स uncertainty will be later operator एडेगा and it will lead to under h cos upon 2m omega because this is the value. Minimum energy of a collection of 6 non-interacting electrons of spin 1 by 2 and mass m placed in one dimensional infinite potential well of depth L. So how many particles? 6 पार्टिकल है अपने पास spin 1 by 2 वाले fermions placed in one dimensional infinite potential well. So कितना होगा एनर्जी आएगा वैल्यू? 6 पार्टिकल है ना, तो क्या करेंगे 2 2 2 रखना पड़ेगा अपने. ओके, मीन्स 2 जाएंगे E1 में, 2 जाएंगे E2 में और 2 जाएंगे E3 में. दिस इज हाउ वी विल कैलकुलेट द वैल्यू. सो जस्ट पुट 2 E1 इक्वल टू पाई स्क्वायर h स्क्वायर अपॉन 2m a स्क्वायर. सिंपली 2 पाई 4 पाई स्क्वायर h स्क्वायर अपॉन 2ml स्क्वायर and it will be 9, so it will be 14 pi square h square upon ml square. Now next question, वन डायमेंशनल हार्मोनिक ऑसिलेटर की वेव फंक्शन दी है अपने को ग्राउंड एंड फर्स्ट एक्साइटेड फॉर्म में, सॉरी, और अपने को एक्सपेक्टेशन इसकी निकालनी है साई एक्स की. सो दिस इज गिवन टू अस लीनियर कॉम्बिनेशन ऑफ बेसिक स्टेट. सो एक्स विल बी साई एक्स एक्स. सो b1 0 1 b2 है ना, b1 0 0 b1 1 0 एंड b2 1 1. ओके, so what will happen here? b1 square 0 0 and b2 square 1 1 and b1 b2 0 1 and b2 b1 0 1. So this will lead to 0 and only this one 0 0 and 0 square, because this is 0 minimum for minimum this will be 0. So to minimum this value, what will you do? 2 b1 b2 0 x1 will be our answer. So for normalization, what will happen? b1 square plus b2 square equal to 1. So when you get to b1 b2 equal to 0, so just we can write this value in this term. So b1 plus b2 square minus b1 plus b2 का whole square, so it will be 2 b1 b2 and 0 x1, and it can also be written as b1 minus b2 का square minus 1. Getting my point? Minus 1. So it will lead us to b1 plus b2 square equal to 1. That is b1 equal to minus b2. Minus is not there, maybe mistake in the option. Simply same, adding equal to n plus 1 n plus 1. Now we will study about simple harmonic oscillator. So we are end of the chapter part. So we are having simple harmonic oscillator. Look like this. These are the extreme. These are the x equal to 0. So potential is half k x square half k m omega square x square. This is the potential, and potential is even potential. So in the time independent equation we applies E minus potential psi consider this alpha lambda and y equal to alpha x. So the solution of this equation will be psi by h and y e raised to power minus y square by 2, where h y equal to Hermite polynomial, and the Hermite polynomial equation will be d2h by dy is minus 2y dh by dy plus lambda minus 1h equal to 0. So solution of this equation, what will you do? Lambda equal to n plus 1, we know, n equal to 0, and lambda equal to 2h by h cos omega square when you do this. So lambda 2 by h cos omega. So from this we can calculate divide 2, and this will be this. So n plus 1 by 2 h cos omega, n plus 1 by 2 h mu will be the answer. So 0.1 energy क्या होगी अपने के? Put n equal to 0, 1 by 2 h cos omega, 1 by 2 h mu, and the wave function will be n dot h n by e raised to power minus y square by put minus y square by 2. So just put n equal to alpha 1 dot by 2 raised to power factorial raised to power 1 by 2, and you can have the full eigen functions. It can be even, it can be odd, depend on the Hermite polynomial. If Hermite polynomial is even, it will give you even value. If Hermite polynomial is odd, it will give you odd value, and the value of Hermite polynomial is 1 to y 4 square minus 2 8y cube minus 12y. This is the, and is just put the value in this and you will get simultaneous functions. Very easy peasy. Most easy is simple harmonic oscillator. You just focus on the numericals. Okay, theory is easy. Only read theory 2 times, then start doing numericals as much as you can. So even function, symmetric function with respect to y-axis, odd function with the origin. Odd function जो होंगे, even function are symmetric with respect to y-axis, and odd function are symmetric with the origin. Now points to remember. Expectation value of x of simple harmonic oscillator is 0, x square equal to h square to omega, y momentum is 0, px square equal to h cos m omega by 2, h cos omega by 4, and k is h cos omega by 4. Now points to ponder. For a 1D SHO in ground state, the probability of finding the particle in classical limits is 84%. Think about it. For simple harmonic oscillator in ground state, particle can be found in classical limits most of the time because probability is 84%. And more astonishing part is that surprising part is that it can also be found in the quantum limits. Means it will not found in classical limit, and the probability is 16%. So it is just oppose our assumption. Now what's the currently condition? Put the value psi and psi m. So e minus x square h n x hmx minus input percent by d equal to alpha upon under by 2 raised to power factorial n. Remember that. Just put the denominator here. From here to here it will come to numerator. Okay. Now we'll discuss about parity. What is a parity operator? Simply wave operator. Whenever we apply on any wave function, it will lead us to minus of that variable. Suppose we have applied to wave function with respect to the variable r, it will lead to minus r. So r lead to minus r, xyz minus xyz. Okay, so p square will be p cap, and p cap psi of r equal to p cap minus psi of r. It will again to positive r. So that means p cap equal to plus minus 1. If p cap is giving plus 1, that is even. If it is given by minus 1, then it is odd parity. So eigenvalues are plus minus 1. Now this is very important. R, theta and phi is spectral polar coordinate. So it will be no change in r. Because why it is so? Because what is r? R is the length of the position vector, and length can never be negative. Length will be same, under root x1 square minus x2 square plus x3 square. Between these 2 points, length is fixed, so r will not be changed. Theta equal to pi minus theta and pi plus phi. R is r, pi minus theta and pi plus phi. Now the output of the operator after measurement is one of eigenstate of operator ये तो अपने को पता है ना कि जब भी आप कोई ऑपरेटर किसी पे आइगन स्टेट पे ऑपरेट कर रहे हो तो जो आउटपुट आएगा ना वो हमको पहले से पता होता है। कैसे कि जो अपनी आइगन स्टेट है उसमें से ही कोई एक पार्ट आएगा, ठीक है। दो साइमल्टेनियसली नहीं आ सकते, ये तो लीनियर कॉम्बिनेशन की फॉर्म में आएंगे, है ना। थोड़ी सी टिपिकल बात है पर समझनी पड़ेगी आपको जो बोला मैंने। 10 सेकंड रिवाइज करके फिर सुनो क्या बोला मैंने। एच कैप इक्वल टू दिस, पी कैप एच कैप इक्वल टू दिस, एन वी एक्स इज सिमेट्रिक potential. So it will again to this means p cap h cap equal to h cap p cap, means p cap h cap minus h cap p cap equal to 0, means they are commuting to each other. They are commuted as Hamiltonian and moment operators are commuting to each other for the symmetric potential. Always remember for what? Symmetric potential. So because it is commuting for symmetric potential, so for symmetric potential h cap and p cap are computable observables, means their values can be calculated simultaneously with infinitely precision. ओके, अब बात समझ में आ रही होगी धीरे धीरे शुरू से अपन क्या डिस्कस कर रहे हैं। दिस इज द प्रूफ ऑफ दिस व्हाट आई हैव सेड। नाउ पेरिटी ऑपरेटर इज ए हर्मिशियन ऑपरेटर, रिमेंबर दिस। नाउ sin lm r theta phi sin lm for hydrogen wave function we will use this, for hydrogen atom we will use this r and lr, and variable separate method will use y element theta phi. So we are just have divided psi into variable r and theta phi. This is called radial part, this is called spherical harmonics. So parity when applied to sin ml r and l r is even because no change in length, but when you apply to theta and phi, pi minus theta and pi plus phi, and formula is minus 1 raised to the power l. Okay, so whenever you are applying parity on hydrogen atom wave function, then radial part will not be changed, but the spherical harmonic part will be changed, and the parity will be even or odd depend on the minus 1 raised to the power l, explicitly depend on l and n2. Now we are having symmetric 1D box with infinite energy. So this is infinite energy in symmetric box. So how we will write this? We go inside 0 and outside infinite. So अब तो पता नहीं कितनी बार कर लिया है, कर दो वेव फंक्शन लगा दो, फर्स्ट और थर्ड में 0 हो रहा है, सेकंड में लगा दो, एंड विल लीड टू, है ना। 2a क्यों आ रहा है? क्योंकि माइनस ए से प्लस में है, 0 से ए नहीं है ना, ध्यान रखना। इवन ऑड दोनों आएगा, एंड विल लीड टू वैल्यू एन स्क्वायर पाई स्क्वायर के अपन एटम एस स्क्वायर। किस में आ रहा है ये? इनफाइनाइट एनर्जी वाले में। किस में आ रहा है? इनफाइनाइट एनर्जी वाला, सिमेट्रिक है और इनफाइनाइट एनर्जी वाला है। नाउ हाइड्रोजन एटम, सबने को बताया बोर की एटॉमिक थ्योरी क्या थी, बोला था कि स्टेशनरी ऑर्बिट है, एंगुलर मोमेंटम विल बी इंटीग्रल मल्टीपल ऑफ h अपॉन 2 पाई, एंड फ्रीक्वेंसी इमीडिएट विल बी h डिफरेंस डिवाइडेड बाय h. दिस इज द simple things we know. Now hydrogen spectrum, molecular lambda equal to rz square 1 upon n square minus 1 to n2 square, n is greater than n2. So for Lyman series what will happen? N equal to 1, n2 equal to 2 3 4, and what is the value of r? 13.6 electron volt or 1.097 10 to the power 7 meter inverse. So just put n equal to 1, n2 equal to 2, 3 by 4 r, similarly 8 by 9 r, 15 by 16 r. It will be in ultraviolet region, and the limit of this region is 13.6 electron volt for ultraviolet region. Balmer series is in visible region. For Balmer series, n1 equal to 2, n2 equal to 3 4 5. So just put the value for infinite, r by 4, here r by 9. So UV visible and then far infrared. Now we will do quantum mechanical treatment for hydrogen atom. psi of v of r equal to माइनस ई स्क्वायर अपॉन 4 प्लस नॉट आर, ये अपना पोटेंशियल होता है। क्यों? क्योंकि ये कौन सा है? कोलम्बिक वाला है ना, के जे डी स्क्वायर अपॉन आर वन आर टू आर, के क्यू वन के टू बाई आर, सॉरी। So potential is spherical symmetric potential. This is the equation. And what is del square? 1 upon r square del by del r square del by del r, 1 upon r square sin theta del by del theta sin theta del by del theta plus 1 upon r square sin square theta del 2 pi upon del phi square. So you just have to remember this. Many times it can be asked. Put psi here. A minus v are equal to 0. Solution: r theta phi, r is spherical and radial part. Now what are the quantum numbers? This is the principal quantum number. Orbital will be L equal to 0 to n minus 1. Maximum will be L equal to n minus 1. And m is minus 12 cell plus L. So L is 0, 1, 2, 3 SPDF shape cell, SPDF subshell, and KLM is B shell. So KLM shall represent n1 equal to 1, 2, 3. This is subshell. When n equal to 1, what is the maximum number of L? 1 minus 1, 0. So only 1 is possible. When n equal to 2, L minus 1, 2 minus 1, 1. So 0 and 1 both are possible. So 0 and both are possible. For this, n minus 1, 3 minus 1, 2. So 0, 1, 2, 3 are possible. So for 1s, NLM 1, 0, 0, phi, theta, r. So remember this 1 upon dot pi cube e minus r upon r naught. Orbital angular momentum under L plus 1 h cross. This will be the probability. So probability is not depending on the time. So probability is stationary. This was the phi. If we square it, we are having 1 upon pi. So the probability of finding the electron at a particular azimuthal angle of 5 is constant and does not depending on the angle. So the electron probability density are symmetric around z-axis regardless of the quantum state. This should be remembered. What is the value of expectation value of r? A square a by a naught by 2, both sides is by 2, 3h square minus l plus 1. If we do square, a is naught square h square by 2, 5n square plus 1 minus 3l plus 1, 1 upon r equal to 1 upon n square a naught, 1 upon r square 1 upon n cube a naught square, l plus 1 by 2. Important. In next class we will study about some questions. This much question we will study. Look at, have a look. So you can also attempt this. If you don't want to attempt, I will solve this. So now my throat is paining. गला दुखने लगा है. पानी पियेंगे थोड़ा सा है ना, उसके बाद आगे क्वेश्चन करेंगे. वीडियो लंबा तो है पर पढ़ा होगा तो मज़ा तो आएगा ही सही. नहीं पढ़ा होगा तो बधाई हो, बहुत अच्छी बात है. फिर तो वो इसकी प्रॉब्लम जो है वो दूर हो जाएगी. माइक खरीदने वाले हैं जल्दी से अच्छा वाला. सो थैंक यू.